All right. Welcome, everybody, to College Algebra 1414. This is section 1.4, solving equations. Hang on, let me time myself really fast. I'm going to try not to go over an hour, but we'll see. If it happens, it happens. Okay. So today's all about solving equations, just using all the algebra skills we know so far to solve these types of equations. I think we'll have radical equations, solving equations by U substitution, and then just solving equations by any method. Okay. So let's get started. All right. First up is solving a radical equation. You have the cube root of 2x minus 4 minus 2 equal to 0. Our job is to solve for x. So in order to solve for x, we must get rid of that radical. And one of your first steps to getting rid of a radical is to isolate the radical. So what we're going to do is take that -2, add it to the right side. And then the next thing to get rid of the radical is to raise it by its reciprocal power. So when I say reciprocal powers, for instance, just know that the cube root can be written as, or this cube root can be rewritten as 2x minus 4 to the 1/3, right? This is by exponential properties and radical properties. So in order to get rid of the root, you need to raise everything by the reciprocal of that given power. So if it's a cube root, to get rid of the root, to get rid of the radical, we must raise everything to the third. And that's what we're going to do. So I'll put parentheses, say parentheses. Ooh, so hang on. The screen's all greasy. I should be writing this way. All right, 1. All right. The cube root of 2x minus 4. Oops, keep the same colors. Equal to parentheses 2. And we are raising everything again to the third. In which, on the left side, the cube root and the third power will cancel each other, giving us 2x minus 4 on the left side, and then on the right side, 2 cubed is going to give me 8. All right, perfect. Now the radical is gone, which makes it easier to solve for x. So add that 4 over. Yeah. Add that 4 over, and you get 2x equals 12, divide by 2, and x equals 6. And there is our solution. And of course, you can always check your work by plugging it back in. Is that right? Don't check your work, she said? Okay. All right. So plug it in. The cube root of 2 times 6 minus 4 equal to 2 would give me the cube root of 12 minus 4 of 8 equal to 2. And that would give us 2 equals to 2, which checks out. Okay. So there's our first one. Not bad, right? Okay. Now, number 2, same exact thing here. So you have the square root of 2t minus 1 equal to 1. So it is a square root, which means in order to get rid of the square root, you must raise everything to the second. Yes, Mama. No, somebody doesn't like math. All right. So I'll write this out here. And we square both sides. Yeah. So square both sides and we get left with 2t minus 1 equal to 1. And all you have to do now is solve for t. All right. I'll take you off the video. Add the 1 over, you get the 2, divide by 2, and we'll get t equals 1. And of course, if you check it, it's going to work. All right, small pause. Okay, resume recording. No more baby, or baby, just a teddy right now. Okay. All right, so we solve this one, square both sides, and solve for t, we get 1. If you check it, it definitely works. So now we move on. Get some tougher ones going, right? All right, like number 3. Again, we want to solve for x, so we must get rid of the radical. Lucky for us, the radical is isolated, which means we can get rid of it. It's a square root, so all we have to do is square both sides. Okay. So I won't color code it this time. You'll have parentheses x minus 1 squared equal to x minus 7 squared. Okay, so now we square both sides. We are allowed to do this because it's an equation, and now we simplify. The left side, the square root, and the square will cancel. So we get x minus 1 equal to, now the right side, we have to expand. X minus 7 squared means x minus 7 times x minus 7. Which means now on the right side, we are going to have to FOIL. One of your favorite F words, I know. X minus 1 equal to, you FOIL the right side, and we should get x squared minus 14x plus 49. Okay, now move the x and the minus 1 both to the right side, leaving us with 0 on the left and x squared minus, if I move that x over, I should get 15x. If I add that 1 over, I should get 50. Okay. And now all we have to do is factor. So this is now a quadratic equation, which means we can solve for x. And one of the ways to solve a quadratic equation is to factor. So 0 equals, and this is minus plus, so you should have x minus a number, and x minus a number. And what are two numbers when multiplied make 50, but when added or subtracted make 15? And that's going to be 10 and 5 or 5 and 10. And of course, you can check your work if you want by foiling it back out. X squared, negative 5, minus 10, negative 15, negative 10, negative 5, positive 15. Boom. Factored, correctly factored, solve for x. X equals 10, x equals 5. But now, who works, right? Oh man, dude. Start. Okay. But now we want to see which solution works. So, yes, we are gonna have to check. And I'll do 10, so square root of 10 minus 1 equal to 10 minus 7. Square root 9 equals 3. And that's already a true statement. Or you can go one more and say 3 equals 3. So 10 checks out. Now we have to check 5. So plug in 5, check it. Square root 4 equal to negative 2. Okay, so this should catch your eye already, because should anything that you take the square root of, so any number you take the square root of, should anything come out negative? And that answer is no, right? So right off the bat, we know this is wrong, but like before, you can keep going and you'll have 2 equals negative 2, which is definitely not true, which means 5 does not work, which means 5 is called an extraneous solution. Or we should just say that 5 is being real extra right now, okay? He's the solution we didn't need, but we got, like Batman. Okay. Okay, cool. So we want to check which solutions work. I'm not sure if my math lab is going to make you check, but it's always good to check. Okay. Number 4, same. But this time we have 2 radicals. All right. So we said that to solve these type of equations, you want to isolate the radical. Well, if we go with that mentality, it looks like both radicals are isolated on the left side. So, and they're both square roots. So it would make sense to square both sides. But there's an issue with that, and I'll show you. This is called, and you don't have to write it down, I'm going to erase all of it anyways. This is called creating the monster. Let's say you square both sides. What you have now just created is a monster, because since you square both sides, you now have 2 of these, which means you are going to have to FOIL them. So this would become square root 2x plus 3 minus square root x plus 2 times square root 2x plus 3 minus square root x plus 2. Now, nobody other than me would enjoy foiling this. So that is your word of caution. Do not create the monster. We have to figure out another way. Yes, you can get to the solution going this route, but I wouldn't recommend it. The only thing it builds is character, which we're going to get enough of this semester, okay? Okay, so bye-bye, monster. Let's start over, and let's rethink our process. So the key thing, again, is isolate. Isolate a radical. Isolate a radical, meaning keep one radical on the left side and move a radical over to the right side. With that being said, with our new thought process, with our new method, we're going to take negative square root of x plus 2 and add it to the right side. Yes, you can add that whole radical to the right side. So our next rewrite is going to look like, probably want to write small, let's see, or just enlarge it there. There we go. Square root 2x plus 3 equal to 2 plus the square root of x plus 2. Okay, so what we have done is isolated one radical on the left and created a tiny monster on the right. And now, since these are square roots, what we're going to do is square both sides. So we'll say parentheses 2x plus 3 squared equal to parentheses 2 plus the square root of x plus 2 squared. So we're squaring both sides, and now lots and lots and lots of cleanup. All right, so on the left side, the radical and the square cancel. So 2x plus 3 is all that's left over. On the right side, expand. So now we have two of these tinier monsters, right? So 2 plus the square root of x plus 2 times 2 plus the square root of x plus 2. Okay. Which means now on the right side, we must FOIL. But it's not as bad as the one you saw in the beginning. So 2x plus 3 equal to that 2 and 2, right? So that 2 and 2, you got 4. 2 square root of x plus 2 plus 2 square root of x plus 2. And then again, your FOIL method. Square root of x plus 2 times 2 plus 2 square root of x plus 2. And then the very last one, square root of x plus 2 times the square root of x plus 2. So what do you think happens here? When you have the same term inside a radical, and the radicals are the same power, or the same index, the square root of x plus 2 times the square root of x plus 2, the radical will cancel. So what you are left with is just x plus 2. And I'm putting it in parentheses for a reason. I would always put it in parentheses. Let's say there was a negative weighting out here. It is just wise and smart to put it in parentheses. From the rest of your math career, parentheses are your best friend. Okay. And once again, if you wanted to see that process, this would become once you FOIL the last two, it would become the square root of x plus 2 squared, where, again, the square root and the square would cancel, giving you that. Okay, perfect. All right, so once again, more cleanup. The left side stays the same. 2x plus 3 equal to, here's what we're going to do. We're going to put this 4 and that 2 together at the end. So we'll have 6. And then we'll put this 2 squared of x plus 2 plus this 2 squared of x plus 2 together. If they are the same radical with the same term inside, then you can add the leading coefficients. So this will give us 4 squared of x plus 2. And all that's left over is that tiny, lonely x over there. Okay. The right side is cleaned up, which means we need to simplify more, and we still need to get rid of that radical, that extra radical we have there, that square root of x plus 2. So what we're going to do is take the 6 and the x, move those to the left. So with that being said, we'll have 2x minus, actually, what's a better way to do this? I'll just subtract them. I'll say minus x, minus x, minus 6, minus 6. There you go. Take it back to 0320, right? These x's cancel, those 6's cancel, and what we are left with is x minus 3 equal to 4 times the square root of x plus 2. Whew, I know, almost there. Okay, so you could choose to divide by 4 and make a mess with fractions, or you could choose not to. For your sake, I'm going to choose to leave the 4 on the right side. So what we're going to do now is get rid of the radical. It is isolated. It has a 4 attached, but it's still isolated. That radical is by itself. So it's a square root. So once again, we will square both sides. I'll color code that. Why not? Okay. We square both sides to get rid of the radical. Well, now look at the left side. X minus 3 squared means more expanding. Oh, foil. So x minus 3 times x minus 3. Okay. And now, on the right side, 4 times the square root of x plus 2 squared. Since these are connected by multiplication, you can raise everything to the second power separately. So you'll have 4 raised to the second, which gives me 16. Square root of x plus 2 raised to the second, the square root and the square will cancel, leaving me with, and remember what I said good habit is, parentheses x plus 2. Okay. So now, still lots of cleaning up to do, right? Foil the left, distribute the right. We're almost home. X squared minus 6x plus 9, 16x plus 32. Say minus 16x minus 32 minus 32. Move everything over to the left. Whew, almost there. X squared minus 22x minus 23 equal to 0. All right. Now factor. And lucky for us, the only factors of 23 are 1 and 23. But look at the signs. Minus minus means x plus a number, x minus a number. And since it's negative, the bigger number 23 must also be negative, and the smaller number 1 must be positive. Okay. And solve for x. You get x equals -1 and x equals 23. And done. Whew. That's a mental sweat, right? Well, it's almost done. You have to check your work, but I'll leave that up to the viewer, right? You believe it. You found those numbers, right? Let me mental check. If I plug in -1, that'd be the square root of 1, and then that would be the square root of 1, which would be 0. So 1 is our extraneous solution. '23, that would be 46, 49, that'd be 7, 25, 5, 7 minus 5 is 2. So 23 works. But definitely write that down. I want to save time on the video, so that already probably took like 10 minutes. So let's keep going. Right, excuse me. Okay. All right, so that is solving radical equations. Take your time, isolate, watch your math, work everything step by step. Okay. Next is solving equations that are quadratic in form. So remember, to solve a quadratic equation, we can do it by factoring, we can do it by completing the square, and we can do it by something called U substitution. But the only reason we use U substitution is that if it's quadratic in form. And what that means is, well, look at number 1. You have x to the 4th plus x squared minus 12 equal to 0. Well, if it was quadratic, it would be to the power of 2. But this is to the power of 4. Well, we see that it's 3 terms and set equal to 0. So this has to be some type of equation. And remember that a quadratic equation looks like this. Ax squared plus bx plus c equal to 0. Well, what we can say is that this given equation, x to the 4th, looks quadratic in form, which means it can possibly be solved by quadratic methods, factoring, completing the square, whatnot. So, what we can do is one method called U substitution. Okay, you can choose to use U substitution, and you can choose not to, because you can solve this without substituting anything. I'll show you the U substitution method, and I'll just show you plain old factoring. Okay. Okay. So since this is quadratic in form, if we use U substitution, it will actually put it into quadratic form, meaning it'll change the highest power of x to the 4th into x squared if we use U substitution. So let's try it out. The way U substitution works is you let the middle term equal u. We're making our first substitution, right? We let x squared equal u, or let u equal x squared. So we have now covered a substitution for the middle term. This is now u. We need to now cover the leading term. How do we make a substitution for the leading term? Well, look at the difference. From x squared to x to the fourth, there's a power difference of 2. So in order to get the second substitution for the leading term, all we have to do is square both sides of this substitution. So we will say parentheses x squared squared equal to parentheses u squared, and let's see what we get. You'll get x to the fourth equals u squared. Does this cover the leading term now? Do we have a substitution for the leading term? And that answer is yes. So our leading term is now u squared, which now makes this an actual quadratic equation because we have changed the power into an exponent of 2. All right. Now, let's rewrite our equation in U substitution form. So we will have u squared plus u minus 12, oops, equal to 0. Where from here, we really hope it's factorable. And it is. We need factors of 12 that can make positive 1. So when I say that, I'm like, think of the factors of 12. Like, what two numbers can multiply to equal 12, but also subtracted or add together to equal 1. And when we set that up, look at your symbols. Plus minus means I'll have u plus a number and u minus a number equal to 0. And if you guessed those numbers correctly, they were 4 and 3. Okay. And if you still need help on factoring, let me know. We can run through it in class, right? I don't want to spend a lot of time on these notes going over it because you should know it by now, right? But it's okay if you don't. Come to me. Okay. So u squared, negative 3, positive 4, 1, negative 12. Now solve for u. U equals negative 4. U equals 3. But we're not done because we made a substitution for u. So look back over here, and what is u equal to? U is actually x squared. So we need to bring that substitution back. So u is x squared. So we bring back the substitution, and now it's put in the format for us to solve for x. Okay, which means in order to solve for x, we have to get rid of that square, so we will just square root. And if you look at the first one, what happens when you square root a negative value? we'll get a domain error, but other than that, we have learned that we will get imaginary values. And then another fact from when you square root on an equation, right, on a quadratic, you should have two values. So we should get plus or minus 2y for the first one. And then for the second one, the square root of 3 is the square root of 3. So we're going to get x equals plus or minus the square root of 3. All right. What time am I on? Oh, we go. 30 minutes. Okay, not bad, not bad. We're moving. All right. Okay. And then I said I'll show you the way to do it without U substitution, because maybe substituting things is too confusing and you see it another way, which is totally fine. We do not need U substitution. Unless it's really, really, really difficult. Because it's there to make your life easy, but if you don't see the substitutions going on, then I'd say avoid it. Option 2. All right, just factor it. That's all you have to do. If you want to get to x to the 4th, then this should be x squared plus a number, x squared minus a number, and you guessed it. You already factored it down below. This factors to x squared plus 4, x squared minus 3, set them equal to 0, and guess what? You're right there, and we were done 20 minutes ago. My goodness. That's it. That's why sometimes we need U substitution, sometimes we don't. Okay. Perfect. Let's move. Like this one, I would use U substitution on. There's 3 methods. Use U substitution, factor it as it is, or 3, FOIL and distribute everything out and then solve for x, which that number 3 is the really long method. So I just want to try U substitution again to get us familiar with it. And then I'll show the quick method. Okay. So there's our middle term. We're going to call it U, right? U equals x squared minus 1. And then we need to make a substitution for the leading term. So might as well be U squared. And double check. You'll square both sides of this, and you'll get U squared equals x minus 1 squared, which covers that leading term, which puts it into a quadratic form. So it went from being what do we say? An equation in quadratic form, or quadratic in form, and U substitution puts it into quadratic form. Yeah, quadratic in form to quadratic form. Ha, wordplay. All right. Okay. So rewrite, and you'll have U squared plus U minus 12 equal to 0. Hey, this looks familiar, right? So factor it. U plus a number, U minus a number equal to 0. And once again, I'm sure it's the same answer. 4 and 3. U squared, negative 3, 4, 1, 4, negative 3, negative 12. And solve for U. U equals negative 4. U equals 3. But bring U back in. Bring yourself back in. tag in. U was x squared minus 1 equal to negative 4. And x squared minus 1 equal to 3. Because that was U, and now we solve for x. Add the 1 over, x squared equals negative 3. Add the 1 over, x squared equals 4. Square root both sides. Square root, square root, square root, square root. And once again, we should get x equals plus or minus I root 3. And x equals plus or minus 2. There you go. U substitution. All right. Perfect. Okay. Option, easy option, right? But you have to train your brain to see it. It's kind of like an optical illusion. We can factor this like normal. So option 2, I'm going to put brackets to be neat. If I factor this, it's going to be parentheses x squared minus 1 plus 4 parentheses x squared minus 1 minus 3. And that's factored. That's how you would factor it. And set them equal to 0, and guess what? We're right back there. Oh, man. But again, you have to train your brain to see it, right? So those are your options. Okay. Moving on. Number 3. Or it's like number 3 again, whichever. Okay. 2 options here. Do U substitution or isolate that radical. Either way, you'll get the answer. But U substitution might be faster here. Maybe, maybe not. So again, I want you to get used to U substitution, so let's keep running through it. So U is going to equal the middle terms variable. So U is going to be the square root of x, which means we need to cover the leading term, and to get there, you'll square both sides. And we end up with U squared equals x. Does that substitution cover the leading term? Did we end up with x? We sure did. Which means we now have a substitution for the leading term. Okay. Rewrite. U squared plus 2u minus 3 equal to 0. All right. Now factor. And again, hopefully it's factorable. If you come across something that's not factorable, we must complete the square on it. Let's hope we don't have to do that today. It'd be fun. Okay. Let's see if it factors. That's plus minus, which means U plus a number, U minus a number equal to 0. And the only factors of 3 that can make 2 are 1 and 3. And since the middle term is positive, the bigger number 3 must be positive, and the little number 1 must be negative. U squared, negative U, plus 3u is 2u. 3 times negative 1, negative 3. And every time I talk like that, it's me foiling in my head and looking at the camera. All right, just to make sure it's correct. Now set them equal to 0. u equals -3, and u equals 1. But what was u? U was the square root of x in this problem. So bring that back. Okay, and now all we have to do is solve for x, which means we need to get rid of those radicals. So to get rid of the square roots, we must square both sides. So say square, 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 square. And the first one will give us x equals 9. And the second one will give us x equals 1. All right. But you have to see here that 9 is our extraneous solution. Because if we plug it in here, we're saying that the square root of 9 is -3. And is the square root of 9 -3? Not at all, because nothing negative should be coming out of a square root. If it is, it's coming out as imaginary, right? So 9 is our and I think if you even plugged it into the top, I think it might work though. Let me see. 9, no, it wouldn't work. You get 9 plus the square root of 9, so that'd be 6. So you get 15 minus 3 equal to 0. So yeah, 9 definitely would have worked. 1 works. Okay. Like I said, I'll leave the checking up to the viewer because we got to move. I think we're approaching on 45 minutes possibly. All right. Oh, and for a second option, it would be like solving the ones on the very first page. Isolate the radical, square both sides, FOIL, all that good stuff. Since we did it on the first 2 pages, we don't have to do it here. But if you want to check it, go ahead and check it using that other method. Okay. This one, we can definitely do U substitution, right? Or we can factor. I'll show you the factoring thing later. Because you're like, you can't factor that. There's fractional rational exponents. That's impossible. Anything, and remember, anything is factorable. Trust me. Okay, so let's U substitution this. So U is going to be x to the 1/4. And remember, it's always the variable with the lowest power, and most likely, and most of the time, it's the middle term. You never ever include the coefficient. So U is going to be x to the 1/4. We now need a substitution for the leading term. So normally, we would get there by squaring it. But if I square this, we run into an issue. You'll get U squared equals x to the 2/4, or x to the 1/4. Right? Definitely really, really weird. So we need to cover our leading term, and this does not. So we must rethink it, and creating a substitution has kind of been like poof, magic. It came out of the air, but since it's math, if we bring anything out of the air, it has to make sense. So squaring squaring a substitution to cover the leading term, well, that makes sense, but not in this case. So if we can't square it, could we raise it to another power? And that answer is yeah. So if squaring didn't work, let's try cubing our substitution. So if I said u cubed and x to the 1/4 cubed, we would end up with u cubed equals x to the 3/4. Look at that, which covers the leading term. So now this is covered by u cubed. Okay. So when you're making these substitutions, you realize we're getting to do what we want as long as it makes sense mathematically. We can make substitutions all day for things, but they have to make sense at the end. Okay. So you're going to get u cubed minus 9u equal to 0. Hey, that looks a lot easier now, right? So factor out the u, and you'll have u squared minus 9 equal to 0. And what you notice about u squared minus 9 is that it is a difference of squares. Which means this can factor to u times u plus 3, u minus 3 equal to 0. Where you set each term equal to 0, u equal to 0, u equal to -3, and u equal to 3. But remember, u was x to the 1/4. Okay. So we still need to solve for x. And that means we need to get rid of that 1/4 power. Remember that x to the 1/4 is the same as the 4th root of x. So to get rid of the 4th root, all we have to do is raise everything to the reciprocal power of 1. The reciprocal of 1/4, the reciprocal power of the root by 4. I'm done, right? Okay, you get it. So if 1/4 is the power, we must raise it by its reciprocal power of 4. There you go. All right, regroup, come back. Okay, so the only one we can knock out here, though, is we don't have to solve this one because, again, it's an even root, and we should not have any negative numbers coming out of an even root. So we can just go ahead and cross that guy out. Okay, which means now raise everything to the 4th power. All right, and we will get x equals 0, and x equals whatever 3 to the 4th is that 81? I think so. And there we go. What do we got left? 1, 2, 3 problems left. What am I running on? Running on empty. All right. 15 minutes. All right, let's see what we get done in 10 minutes. Oh yeah. With that being said, if you want me to factor that one, I'll do it in class. option 2 type stuff, right? Okay. All right. So number 1, I think these are the solve equation by any method. So basically, just watch me work and have fun, right? Okay. So we said solve by factoring. So that's what we'll do. I see that I have a common factor of x, so I'm going to take an x out. If I take an x out, this leaves me with 1 minus 4 square root of x equal to 0. And all I have to do now is set both of these terms equal to 0 and solve for x. So you'll get x equals 0 and 1 minus 4 square root of x equal to 0. Hey, look at that. That one's done. Now a little bit of solving over here. I'll add that 4 square root of x over. And then I'll square both sides. And 1 will equal 16x. Again, parentheses for good habit. Divide by 16. And 1/16 equals x. Boom. Look how easy that was. You could use substitution that one if you want. It worked the same. All right. Yeah. But moving on, like I said, I don't want to make videos past an hour. I didn't want to make videos past 45 minutes, but that's life. Okay. Next one is a 4-term polynomial. So if you have learned anything from developmental math and factoring, you know that 4-term polynomials can be factored by grouping, which means I'll group the first two, I'll group the last two, and I will factor out the common factors. So from x cubed minus x squared, I'm going to take an x squared out, which would leave me with x minus 1. From negative 4x plus 4, I'm going to factor out a negative 4, which would leave me with x minus 1. And now, when you factor by grouping, these parentheses need to look the same. And they do, which means this is all about factoring, so factor them out. And you'll get x minus 1, which we just factored out, times whatever is left. And there you go. It's factored, but it's not completely factored because x squared minus 4 is a difference of squares. So that'll factor to x minus 2, x plus 2 equal to 0. Now it's completely factored and broken down. Solve for x. X equals 1, x equals 2, x equals negative 2. All right, so cool fact here. How many answers did we get? We got 3 answers. What was the power of this polynomial? The highest power. The highest power of this polynomial was 3. So the degree of the polynomial, the highest degree of the polynomial, tells you how many answers you're going to have. So if that's x cubed, we should find 3 x values. Did we find 3 x values? We sure did. Thanks for coming to my TED Talks. Wait, Ted's back there. Oh, right there. Oh, there you go, right there. All right. Last one. Okay, this one, definitely U substitution, right? Look at that, 2/3, 4/3, so let's do it. U is going to be x to the 2/3, the middle term with the lowest power. And if you square this, you'll get x to the 4/3, which takes care of that. Hey, look at that. Easy. Rewrite. 3u squared plus 5u minus 2 equal to 0. Okay. And now it's in an easier format. We can factor it, and let's hope it's factorable. 3u, I have plus minus. Let's see, I think that my minus should go here. And my plus should go there. And lucky for us, what are the only factors of 2? 1 and 2. And I'm going to FOIL to check my work, but not really, right? I'm going to talk about it. 3u and u is 3u squared. 3u times 2 is 6. 6 minus 1u is 5u. And negative 1 times 2 is negative 2. So we check out. This is correctly factored, which means solve for u. Set these equal to 0. 3u minus 1 equal to 0. U plus 2 equal to 0. It's going to be u equals 1/3 and u equals negative 2. But u is x to the 2/3. And I said it when we had the 1/4. So I said to get rid of a rational exponent is to raise it by its reciprocal. So this is going to be the same situation here. To get rid of that 2/3 power, raise both sides by its reciprocal, 3/2. So raise everything to the reciprocal power and simplify. So on here, these powers would cancel, right? Leaving us just with x. So you get x to the 1/3 raised to the 3/2. And over here, x equals negative 2 to the 3/2. Okay. Now, how do we fix this? A lot of work, right? So remember, we have our our rational exponent properties. So one way I can rewrite this is as x equals the, the square root of 1/3 cubed. And this would be the square root of negative 2 cubed, which means that our work is cut short because can we take the square root of negative 2? No, right? Yeah, we'll leave that alone for now. Let's keep moving. All right. So we're going to focus on this one more. This can become the square root of 1 over the square root of 3 cubed, which would give me 1 over the square root of 3 cubed, which would then, by rationalizing, would give me square root 3 over 3 cubed, and once more into the madness, square root of 3 cubed. That would be 3 square root 3 over 3 cubed, which is 27. And our final answer would be the square root of 3 over 9. There's your solution. My goodness. That was totes fun, right? Okay. That was solving equations. That is U substitution. Remember, you don't have to use it if you can see it. And that is solving radical equations. Okay. And that is it for now. See you in the next one.